Calculation. So you want to show by calculation sodium carbonate is in excess. Alright, so they give you the balance equation here. That is very important. First of all, you're given sodium carbonate, which is a solid. So solid there. So you need to work out the molecular mass of Na2CO3. Get out your periodic table. So there's 23 times 2 plus 12 plus 16 times 3. You're going to get 106. Alright, so the mole of Na2CO3, so N refers to the mole, mass over mR, so there's 3.18 over 106. That's going to give you 0.03 mole of sodium carbonate. Alright, next bit, you can work out the ethanoic acid. Mole is going to be the concentration times the volume. The concentration is in mole per dm cube. This is in cm cube. Convert cm cube to dm cube. You multiply by 10 to the minus 3, or you divide by 1000. Smaller to bigger, right? So you need to know your conversion very carefully. Sorry. Concentration first, based on the formula. Mole per dm cube times 224 times 10 to the minus 3. Put that into your calculator. 10 to the minus 3 simply means 224 over 10 to the 3. That means 224 divided by 1000. You will have learned this in your Maths D as well, I presume. Okay, so what do we have here? So based on balance chemical equation, 2 mole of acid reacts with 1 mole of sodium carbonate. Or I could say the other way around, or I could say 1 mole of sodium carbonate reacts with 2 mole of acid. So I could say 1 mole of sodium carbonate reacts with 2 mole of acid. Same thing, right? So I've just reversed them the other way around. How much sodium carbonate do you have? You will have 0.03 mole of, therefore 0.03 mole of sodium carbonate needs 2 times 0.03, which is 0.06 mole of ethanoic acid. What does it mean? It means that if you have 0.03 mole of this, I need 2 times this much, which is 0.06. But guess what? I only have this much. Since not enough mole of ethanoic acid, in reality, how much do you react? You only reacted 0.056. You need 0.06. So what does this tell you? Ethanoic acid is limiting. It's not enough, right? Therefore, sodium carbonate is in excess. So what have I done there? What I've done is I have shown by the other way. There are 2 kind of ways to show that something is excess or something is limiting. You can either show that it's excess straight away, or what I've done here is I can show the other thing is limiting, because you only react with 2 things, right? If one of them is limiting, the other one is in excess. So that is what I've done here. I could have also shown you that, that 0.056 divide by 2, 0.056 divided by 2 is going to be 0.028. So this will only react with 0.028 mole of sodium carbonate, and this is greater than 0.028, therefore this is in excess. There is another way of showing it. Both way, perfectly fine. Next question is a calculation. You want to show butanoic acid is in excess. So they give you the mass of butanoic acid. So this is butanoic acid. It is C4H8O2. So the MR of C3, sorry, not C3. If I just, I mean, you can work it out there, but I'm just getting the molecular formula so that it's easy to just multiply 12 times 4 plus 8 plus 16 times 2. That's going to give me 88. So the mole of the acid is going to be 5.28 divided by 88. So mass over mR, because it's given as a solid. That's 0.06 mole. Okay. And then the mole, sorry, not should probably be consistent. The mole of sodium carbonate is 56.0, so it's given us a solution there, so times by 0.500, so 56 there times 0.5. So this 10 to the minus 3 refer to divide by 1000. You should be aware of this from your O-level maths course as well. You should be confident to key that into your calculator easily as well. So this is how much you actually react this with this. So what's going to happen is from balance equation, 2 mole of acid reacts with 1 mole of sodium carbonate. Alright, therefore 0.06 mole of acid needs 1 times 0.06 over 2, which is 0.03 mole of Na2CO3. So to react this much of acid, you need this much of sodium carbonate based on the mole ratio, right? 2 mole of it react with 1 mole of it. 0.06 mole of it will react with 0.06 divided by 2 is going to be 0.03 mole. You need this much to react, but you only have this much. But only reacted 0.028 mole of Na2CO3. Therefore, that one is limiting. It is not enough. You don't have enough of it to react, therefore it limits the reaction. If Na2CO3 limits the reaction, therefore the acid is in excess. Alright, because you only have 2 reactants. If one of them is limiting the reaction, the other one is going to be in excess. So I've just shown the butanoic acid is in excess. First off, describe how you would know when all the ammonium carbonate has decomposed. When the ammonium carbonate decomposes, it goes from solid to gas, gas, and gas. So no solid in the product. Alright? When all NH42CO3 has decomposed, no more solid remains. That is quite obvious. I mean, have a look at the stat symbols and you will see they all evolve as gas, right? So if you still have, if you can still see solid, it hasn't fully decomposed. If you don't see solid, that means everything has turned to a gas. Alright, so that's it. It's about observations, yeah, okay? It's got nothing to do with the smell of ammonia or whatever, because these are all colorless gas, so you cannot see them. Alright, now you want the total volume of ammonia and carbon dioxide. You see H2O is a gas also, but you don't want H2O, you want ammonia and carbon dioxide form when you completely decompose it. The good thing about gas is, because they are all gas, the best thing about it is molar volume of any gas is equal to 24 dm cube per mole. Is also equal to 24,000 cm cube per mole. So it really depends on you want your final answer to be in dm cube, then you use this value. If you want your final answer in cm cube, then you use this value. But you should know the conversion from 1 dm cube to 1 cm cube is just multiplying by 1000 anyway, which of course you do. No, yeah? Okay, I'm gonna move this here a little bit. Okay, what else? Because these are gases, so I can total their mole of gases altogether. But first off, I will work out the mole of NH4 twice CO3. So the formula is NH4 plus, which is ammonium ion, CO3 2 minus, which is an ion. The 2 minus, you need 2 of it, 2 of the ammonium to balance it. That's why there's 2 ammonium and 1 carbonate. Better be very good with all your polyatomic, meaning more than 1 atom kind of ion, yeah? It's going to be mass over mR. You are given the mass there, so you need to work out the mR, alright? So the mR of NH4 twice CO3, I hope you can do this easily. 2 bracket, so there's 14 times 1, I will skip the times 1, so it's just 14 plus 4 times 1 is just 4, okay, and then multiply by the 2, all right, and then plus 12, which is carbon, just 1, so 12 times 1 plus 3 times 16. So you can get 14 plus 4 times 2 is 36, 36 plus 12 is 48, plus 3 times 16 is 96. Okay, so that's going to give me 4.80 gram of the carbonate divided by 96. That is 0.05 mole. Alright, now I want the mole of NH3 and CO2 divided by the mole of NH4 twice CO3. What is the total mole of NH3 and CO2? The thing is, I can do this. The only reason why I can do this simply is because they are both gases. So I can total 2 plus 1. There is 3 mole of gas. There is 3 mole of gases, of which 2 is ammonia, 1 is CO2, and they want the total volume of the gas, ammonia and carbon dioxide, reacts with 1 mole of it. 1 mole of it reacts to form 3 mole of these 2 gases. 1 mole of this reacts to form 3 mole of these 2 gases. Gases are very important because now I'm going to use this thing there. Alright, so the mole of the NH3 and CO2 is going to be 3 times 0.05, and you know the mole of the gases is going to be the volume of the NH3 and CO2 divided by 24. So I'm using dm cube per mole, so my volume will be in dm cube because I use 24. Be very careful of your units. Yeah, some people, they just interchangeably use their unit, but they are not doing very good bookkeeping. All right, so if you use 24,000, your answer will be in cm cube because I'm using dm cube there. If I show you, this is mole, 0.15 mole, this is dm cube per mole. So you can write down your unit to be clear. See, dm cube per mole. 1 mole of any gas at room temperature and pressure has this volume of 24 dm cube. Mole and per mole will cancel, so that times 24 is 3.6 dm cube. So you could get 3.6 dm cube. The other thing is, your calculator do not show you dm cube. Okay, volume of gas. Volume is a physical quantity. If you do not put down a unit, it has no meaning. You automatically lose the meaning of the value. Therefore, you will lose some marks. Yeah. Right. Next bit. How would you know? Describe. How would you know when all the ammonium iodide has decomposed? This is a gas. This is a gas. This is a solid. So if you still have a little bit of solid, that means it is still decomposing. But if everything turns to the product already, there's no more, this gas will have escaped. That means there's no more solid. Okay, so when all the solid has disappeared, that means no more solid can be seen. Disappear, then all would have decomposed or reacted, as the products are gaseous. As the products are both gaseous, and they will escape, obviously. Yeah? Now you want to do some calculation. You want the volume of gas. You see that's tricky there? Gas. How many gas are there? There's 1 gas and 2 gas. 1 mole and 1 mole. So there's NH3 and HI. Altogether, 2 moles of gas are formed from 1 mole of NH4I. Okay, because these are gas, the molar volume of gas at room temperature and pressure is 24 dm cube per mole. This is also equal to 24,000 cm cube per mole, so it depends on which value you want to use. Alright, so I'm going to get started. So the mole of gas over the mole of NH4I is going to be 2 over 1. Why you say it's not 1 over 1? Because they want gas. They want the gas, which is both ammonia and HI, So altogether there's 1 mole of gas and 2 mole of gas. 2 mole of gas are formed from 1 mole of NH4I. You don't need to write this, I've just written this down if you cannot see what I'm talking about. Okay, 2 moles of gas are formed from 1 mole of NH4I. That's the confusing bit here, yeah? You should probably be aware that you're given the mass of ammonium iodide. So you should have MR of NH4I somewhere. Alright, so if you take a look in your periodic table for the atomic mass of iodine is 127. So that's 14 plus 4 times 1 plus 127. So that's 145. Okay, so the mole of gas is 2 times the mole of NH4I. Okay, so the volume of the gas divided by 24, I'm going to use dm³ per mole, dm³ per mole, so this volume of gas is going to be in dm³. They don't give you the unit, you got to specify, you got to be aware of what you're using. Here I'm using dm³ per mole, this volume is in dm³. If you use 24,000, that's in cm³ per mole, then your volume of gas will be in cm³. This represents mole of gas. On the right hand side I have 2 times the mole of the solid, which is mass over the MR, which I just calculated there. Alright, bring up the 24. The volume of gas will be equal to 24 times 2 times 2.90 divided by 145. That is 0.96 dm³. I said dm³ because I use 24 dm³ per mole. Alright, so that's going to be 0.96 dm³. The problem with a lot of people is, a lot of students, is that you are not aware of units. The other thing is your calculator do not show you units, they show you value. So you will just write down 0.96. But this is a physical unit. If you have done physics, if you've done maths, you know units have a meaning. Without the units, this 0.96 has no meaning at all. Okay?